3. I'm now going to point out what these things in parentheses have been meaning. You see how this says SSA? That means side-side angle. That means you have two sides and an angle. I remember this. This is a case where we could have two answers. I remember this because if you switch up the letters, it resembles a cuss word. So that's kind of the one that stinks is the one that stinks, if you get what I'm saying. Let me go back to the previous two examples we've already done. This first one said AAS. That would mean angle, angle, side. If you have angle, angle, side, you'll always get your right answer. No worries about it. If you have angle, side, angle, meaning angle, then a side in between the second angle, you'll always get the right answer. And I should be saying that order doesn't matter here. This would mean here that you were here, we were given an angle, followed by a side. Look, angle, followed by angle, followed by the side. That's what we had here. This one, we had an angle, followed by a side, followed by an angle. What did they give us? They gave us this angle, followed by this side, followed by this angle. Now we're at a case where they say we're given a side, then the angle. Or again, you could start from the other direction, say an angle, then a side, then a side. So here's what we could have. It says if in a case where it's talking about angle A here, and the one that's less than 90. It's not talking about the one that's greater than 90. It's talking about the one less than 90. If angle A is less than 90, and that side length A is shorter than the height and the side length B, there's going to be no real solution. As you can see here, the triangle doesn't connect. If A is less than B and A equals the height, that means that we have the A is exactly height. Well, it's a right triangle, and we could solve with our normal psi y cos x tangent is y over x. That's what we've been working with when we have a right angle. But here's where it gets tricky. It's when A is less than B and A is less than height, you could actually have two solutions. You could have it going, because again, they're giving you a side, and an angle. Or, said another way, the angle, the side, and the side. If they only give you this angle and these two sides, you don't know if this side is going here or here. So you'll just have to solve twice. As you can see, there could be two answers. This is resembling a circle here, just showing that you can connect the triangle this way, you could connect it this way, and it would not change this angle or this side. There would be two solutions. But an easy one is if the A is greater than the B. If A is greater than B, there's only one way to get the answer, and that's to move the triangle this way, and so that the angle that's over 90 is right here, which we call C. If this is A, this is B, this would be C. All right, here's some more pictures down here you can look at if you need more help. But let's look at this. It says the ambiguous case. So now, I've already given you the picture. Here's what we're working with. They've given us an angle, a side, and a side. So this is the case that stinks. This side happens to be shorter than the height ever would be. And you could do this by a sine value. Remember that sine of the angle on the x, if this is the x-axis, here's your height. Sine would be 63 equals this actually means the y. They call it h for height. H over the hypotenuse of 25. We'd be one step away. If you do this and multiply it, you'll find that this is greater than the 18. And so you'll find out that there is no actual way of getting an answer. So when I type this in the calculator, 25 times sine, times sine the angle was 63 degrees. You type this in, I want to find out that height is bigger than 18. Yeah, it's 22.3. So over here, this height is 22.3. That runs into problems because if that's 22.3, this 18 will never reach. So there's not going to be no solution here. We could determine it that way. But had you not had the drawing and you had to solve this, well, what would you do? Well, let me show you. So you would start with, we do our drawing. We would know this is 63, we know this is 25. Let's say we did not know, we hadn't drawn a scale, so we didn't know if this 18 touched or not. Well, you could set it up and say, well, I do have a completed set. I have angle A and side length A. So I'd say sine of 63 degrees over 18 will equal some value over here, which I don't have, sine of, we'll call it B over side length B. And then I would do my cross multiply and divide like we've done previously. So I would have 25 sine of 63 equals 18 sine of b. And I want to divide this by 18. And then lastly, there's one more thing we'll have to do. Notice that we'll have 25 sine of 63 degrees over 18 equals the sine of b. Well, to get b by itself, I'm going to have to do the inverse because I want to switch these two. Since I want to switch these two, because I don't know what sine b is, I'm going to end up saying b degrees will equal 25 sine of 63 degrees over 18. So that's actually what I needed. Well, I switched this and I forgot to do the inverse. I'm sorry. Let me go back here. Luckily, I left myself a little space. I'm going to need to do here equals sine inverse of all that. So I just switched those two. So we go to our calculator. Something that's very important, we need to check our mode. I am right now in the radians mode. I can tell because when I click up there, it said angle rad, which means radians. So I go to document settings. I'm going to change this to degrees. I hit make default. And so this will now work. I need to do the inverse sine. And I had a fraction. And up on the top of the fraction, I had 25 sine of 63. Oops. 25 times the sine of 63 degrees. And all of that was divided by 22, I believe. Let me check it. No, 18. And I hit enter, and it says undefined. That would be my signal telling me this is this triangle does not connect, so this is, again, no solution. This is undefined, which would also imply that there is no solution. So that's the two ways of doing that. Is one, to check to see if A is greater than the height. It has to be greater than the height for this to work. If it's not greater than the height, we're never going to connect. It doesn't matter which way you go. Remember, if it was equal to the height, we'd have a right triangle, and that'd be great. But if this needs to be greater than the height, they even have a triangle. So here's part B. This time I have the drawing, and you can see I do have a complete set here. It's given me an obtuse triangle. The only thing you have to check if A is obtuse is this side. The side will be bigger than the ones that are not obtuse. So as long as this side is bigger than this side, we're good. In this case, it is. So this should work. So I'm going to go through our normal progression of signing. I have a complete side. Here I have sine of 105 over 73 will equal the sine of any set, or a set anywhere. So let's see, find the solutions for the given triangle if possible. If no solution exists, write no solution. Around the side lengths to the nearest tenth, and the angle measures to the nearest degree. So we're going to find everything in here. So let's start with angle B. So I'm going to say sine of B is equal, or rather over 55 will equal this completed set. I do my step of cross multiply and divide. So I'll have 55 sine of 105 degrees is going to equal 73 sine of B degrees. And I should have put that degree symbol up here. Let me add that right there. Okay, to solve, the first step would be, I'm trying to get B by itself. I divide by 73. But I still have one more problem here, is even though that goes away, I still need to get rid of the sine. So remember, we're going to end up doing inverse, because right now I have 55 sine of 105 degrees over 73 equals sine of B degrees. If I need to solve for B, I need to do an inverse sine so I can flip those around. Remember, inverse switches, normally most things it switches the x and y, but when it comes to trig, it switches the angle and the side lengths. So I will say B degrees will equal sine inverse of 55 sine 105 over 73. When I type this in the calculator, it should give me my answer. And I want to point out, you could have solved from the very start up here, but we'll go through and solve this now. So I go to my calculator, And I will say that I'm looking, actually we already have a good model right there. I'm going to take this, I'm going to press up twice. Once I'm highlighting, press enter, it'll copy it down. I believe we had sine of 55 times sine 105, all divided by 73. I'm getting 46.698. 46.698 for the B. So B equals 46.698 degrees. It's said to round the nearest angle to the nearest degree. So we're going to say this is approximately 47 degrees here. So I'll put that right there. Now if angle B is 47, I can now find angle C. So I take my 180 and I subtract the 105, which was angle C, or angle A, I'm sorry, which leaves me with 75 degrees to work with. Then I subtract the 47 that we just found from angle B. And this gives me, when I subtract that, 28 degrees. That will be our angle C. That is 28 degrees because every triangle has a total of 180 degrees. Now that I know that, I can solve for my missing side length here. I'm going to use law of sines. I'm going to come back up here. And I'm going to use the original they gave me, the sine of 105 over 73 equals the sine of 28 degrees over side length C here. And so I'll put C. Now, if I wanted a better answer, I would use the unrounded, which would we'd need to use this to find the unrounded. But for now, I'm just going to use the rounded value we already have. So we'd cross multiply and divide. And so we'd have 73 sine of 28 degrees equals C times sine of 105. Now this one will be easier because I'm looking for side length, not the angle. So I divide by sine of 105, and this should give me my answer. So 73 times sine of 28. We have a big fraction here, 73 times the sine of 28 degrees, and all of this is divided by sine of 105. Sine 105, type that in degrees, I press enter, and we get 35.48. 35.48. 35.48, and it's said to round side lengths the nearest tenth. So we would say this is approximately 35.5. And that's how you would solve the triangle using the law of sines. So now you have another one to try here.